Hello everyone, welcome to Webutorial.com. We bring you world's hardest easy geometry problems. There are two such problems and they are drawn over here. In both these problems, we have to calculate the value of this angle x and over here angle x. In these two problems, what is common is that the angle at the base is same. Both are 80 degrees each in both the problems. But the difference lies in how the angles are split, and they will lead us to different approach in solving these problems. So let us try to solve our first problem. So let us take a look at our first problem. In this problem, what is present over here is that we have been given two angles over here and here which are of importance. That will give us the hint how to solve this problem. If you observe, angle DBE is 2 times angle DAE, and both of these angles are present on the same side DE. So we remember one of the theorems in circle in which if we have this circle, this is the center, we have a chord, angle subtended by the chord at the center is double the angle subtended at any other point. Okay, so in this problem also we can imagine a circle which is passing through AD and E, and it has a center at B. Okay, the figure is not drawn to scale, so pardon me about that. Okay, and you can imagine, right? So now we have to find this angle x. All right, now angle x is present on the chord DA. Take a look if DA subtends anything at the center B, and what we found that angle DBA is 60 degree on the same chord DA. Therefore, angle DEA will be half of 60 degree, will be 30 degree. So this is the solution. Now we will take a look at the second problem. Alright, this is our second problem. What happens over here is that if you go by the same analogy, this is 20 degree, this is 30 degree. But then the double relation is not there, so obviously you cannot use it. We have a 60 and a 30 over here, but again 60 is present on side EB and 30 is present on side DE. So obviously that circle analogy is not going to work. What we will do over here is that is kind of very innovative. Okay, so let's try to see how this problem can be solved. Alright, first of all, let us try to find whatever angles we can find, and we can see that in triangle AEB, angle AEB will be 180 minus 60 minus 80. Okay, 60 is from here, 80 is from here. Okay, and this angle we are trying to find. This is the angle that we are trying to find. So what we can write over here is that AEB is 40 degree. Okay, so this angle is 40. All right. Similarly, in triangle ADB, we can see that angle ADB will be 50 degree. Okay, this angle is 80, this angle is 50, so this angle also has to be 50 degree. All right. What is important over here is that if this is 50 and this is 50, then this side must be equal to same as this side. Okay, so far so good. Now what we will do over here is that we will draw a line parallel to AB through E. Okay, let me choose a different color. Yeah, this is better. Okay, then let us join this point with B, and we have a point of intersection. Let us call it G. So this point is G, and let's call this point as F. Okay, and also join this line DG. Okay, now we will try to see what is going to happen in this problem. All right, first of all, observe in the trapezium ABEF. What is observed in this case is that we have a trapezium in which the base angles are both equal. All right, let me just draw it for you. So it is given that these two base angles are both 80 degree. So this angle will be 100 and this angle will also be 100 degree as these two lines are parallel. Okay, what is important over here is that these two angles, the opposite angle, add up to 180 degree. That means ABEF is cyclic. If it is a cyclic trapezium, then again we can imagine a circle around it which passes through the points A, B, E and F. Okay, if we have a circle like that, this angle will be same as this angle, and we can call this angle as 40 degree. Okay, this angle, this total angle is going to be 60 degree because it is alternate with this, and this angle also is going to become 60 degree because this angle is present on the same chord EB and it subtends this angle as 60 degree. So I'll just write down these things for you. What we have found is that angle GFE equal to angle FEG equal to 60 degree. Okay, this means that triangle FEG is equilateral. This means that FE will be same as EG will be same as FG. Okay, now take a look in triangle GAB. What it happens is this: since this angle is 60, this will also be 60, this angle is 60, therefore this is also equilateral. If this is also equilateral, what we can observe over here is that GA will be same as GB will be same as AB. Okay, take a look at this result. We had found that ADB is 50 degree and AD was same as AB. Okay, so AD is same as AB. We have AB over here, we can write AD over here as well. Now observe this GA and AD. Since these two are same, that makes triangle ADG isosceles. Alright, now this triangle over here is isosceles with something like this. This is isosceles, this angle is 20 degree. So obviously these two angles are going to be 80 degree. Okay, so angle ADG equal to 80 degree. This implies that angle FDG is going to be 100 degree. Okay, take a look, let me draw a line in triangle FDG. In triangle FDG, what is happening is that we have an angle FDG 100 degree, we have this angle as 40 degree that we had found over here. Let me locate it for you. This angle over here, we had found this angle to be 40 degree. So the other angle over here will also become 40 degree. If this thing is happening, then what we can say is that FDG is also isosceles. If FDG is also isosceles, then we can say that DF is same as DG. Okay, now take a look at this quadrilateral over here, which is D, G, E and F. In this case, we have got DG same as DF and EF same as FG, which makes it a kite. And in this case, the diagonal is just drawn over here, so it will bisect these two angles and both these angles will be 30 degree, which is the solution that we were looking for. So take a look at this again. What we have done is that we drew a parallel line, then we were able to understand this trapezium to be cyclic trapezium. Then we have proved two triangles, one over here, the another one over here, as equilateral. Then we proved this triangle to be isosceles, then this triangle to be isosceles, and proved that this quadrilateral was a kite. This is how we arrived at the solution for this. So these were the two hardest problems in geometry, and this is very popular on the web. We bring these concepts and we teach you how to use these concepts in our regular classes. You can take a look at the complete solution in this new, much better looking sheet. So this is the solution for that. Now I'd like to introduce the classes that are coming from Webutorial.com, and they are on this page. Webutorial.com is going to bring two crash courses on Independence Day. For the first crash course is going to be on geometry, the second crash course is going to be on numbers. This will be applicable for CAT. The price is 99 each for both of them, and as you can see, it will be a 3-hour class. We will solve various CAT questions and CAT grade questions. Alright, now another classes that we are bringing is regular classes, and the last batches, they will be the last batches for CAT 2013. One of the batch will be on PNC and the other batch will be on numbers. PNC batch will have 4 classes, each of 2-hour duration. Numbers will have 6 2-hour sessions each. PNCs will be on Saturdays, numbers will be on Sundays. For more information, you can log on to our Facebook page, which is facebook.com/Webutorial. All the information is easily available over there. I hope you had great experience in seeing this video. Thanks a lot.